Okay, so everybody knows that the primitive of e raised to x is just e raised to x. But what do you think the integral of e raised to root x with respect to x is? Now, to carry out any question like this, I just start with a general substitution. Over here, just blindly substitute something as u. You can clearly see that the odd one out is root x. So let's take root x to be u. And now you know that du upon dx is just derivative of root x, that is 1 over 2 root x. So du is just 1 over 2 root x, and then take the dx to the side, making this dx. Now, whenever you carry out any u sub, there are two things that you can do. One thing is that try to connect the function with the derivative. But in this integral, we just have e raised to root x. So yeah, we don't need to connect the function and the derivative in any form. Another thing that you can do is completely isolate dx out, create something else. And that's exactly what we can do. So over here, we can isolate dx out, completely replace that in our integral. So to do that, you need to isolate dx, so just directly cross multiply. This is just du over 1. So dx is just equal to 2 root x times du. Now, by the way, take this as equation 1. So then sub equation 1 in this equation. So wherever you see root x, sub u in there. So dx is just 2u times du. So now we've understood where to go. Now let's take a look back to our integral, that is e raised to root x. Again, we took root x as u. So this integral just changes to e raised to u. Integral of e raised to u times dx we had taken as 2u du. So now this is 2u du. And there you have it. We've transformed this into a whole new integral, and now we just need to integrate this with respect to u. So clearly you can see that over here we have two different functions. So we need to apply the product rule of integration. And how do you do that? Basically just integration by parts. But to do that, what I'm going to do is I'm obviously going to have to break it into two parts, two different functions over here. Now you tell me, which function is easier to integrate with respect to u? E raised to u or 2u? Obviously e raised to u, because integral of e raised to u is just e raised to u. So what I'm going to do is I'm just going to pair e raised to u with du, because we're going to need that in our formula. So what we're going to do is I'm going to take 2u as one thing and e raised to u du as another part. So now we have two parts, again just like two parts, integration by parts. So now whenever you have integration by parts, you have two variables obviously. Let's say the two variables are t and v. So now the formula of integration by parts is very easy. It's just integral of t with respect to v is equal to product of t and v. tv minus integral of this time v with respect to t. So v dt. And this right here is the formula of integration by parts. So now let's do some more substitution over here. We've already done substitution, but we need to do even more substitution. So what we'll do is we'll take this whole thing as t. And this though anyways it's in the form of du. So we'll take this as dv. So we have t is equal to 2u, and then dv is equal to e raised to u du. And now because we found this, we can find the derivative of 2u, that's just 2. So then we can say that dt is just equal to 2. And then we can get v also very easily. V is just e raised to u. And that's pretty much it. We have the values of t, dv, dt and v. So now all you need to do is sub this in this. Integral of t dv, integral of t over here is just 2u, and then dv is just e raised to u du. Now this is exactly what we need to integrate, right? This is exactly what we need to integrate. So now this thing is equal to, we have t and v, the product of t and v, that is 2u times e raised to u. So 2u times e raised to u minus integral of v dt. So over here we have v as e raised to u, and then dt as 2. So it's just twice of e raised to u, and obviously this will just be with respect to u. So now we need to carry out this integral. So now again just casually integrate this. This is just 2u e raised to u minus 2 was a constant here, so chuck it out. You don't even need to integrate it. This is useless. Now we look at integral of e raised to u with respect to u, and that is just e raised to u. That's why I paired these two up. So this is just twice of e raised to u plus c, and that's pretty much it. That's exactly what we needed. This is our answer. So now wherever you see u, just replace that with root x. So it's twice of root x times e raised to root x minus twice of e raised to root x plus the constant c.